Hello and good morning. It's about -25 out right now, but we're going to do our physics project for you. Today Alex and I will be explaining the physics of hockey. We'll be explaining 3 different parts of the equipment used in hockey, beginning with the skates, the puck, there's one in the net down there, and finally the slap shot. So we're going to do that for you today. Hope you enjoy it. Alright, so first we will be explaining the importance of the skate and how the laws of physics apply to it. The skate edge enables the player to cut into the ice and make sharp turns, speed up and stop. And there is very low friction between the skate and the ice, which allows the player to glide across the ice very easily. Also, the physical makeup of the ice is what allows the player to player's skates to dig in easily. As the player pushes off his or her leg, a perpendicular force is exerted on the skate blade by the ice. The component of the force that points forward in the direction of motion is what pushes the player forward. Then the other skate or leg is either in the leg or gliding across the ice. The player then pushes off with his or her other leg. Alright, so Brain here is pushing off the ice with a perpendicular force. When he is pushing off, his skate glides across the ice with very low friction, which allows him to glide easily across the ice. Alright, so Brain here is going to stop, and the makeup of the ice, it makes it very easy for him to come to a sudden stop, which also helps with the skates, with the edge, to make it stop very easy. Alright, I will now be explaining to you the physics of the hockey stick, but first we had to come inside because it was very cold outside. We got a little frostbite, and our phones kept on dying, so we couldn't film, so we had to come inside where it's a little bit warmer. Alright, now on to the physics of the stick. The hockey stick has several different features. It is designed to enable good puck control while also being lightweight and strong enough to withstand the stresses placed on it during use. Well, one of the key features of the stick is the blade. The blade has a nice curvature that acts as a self-centering device for you when you're controlling the puck. Alright? And when the puck strikes the blade, the curvature of the blade forces it towards the very bottom of the curve, right here, where it sits for a brief time. This allows a player to make more consistent shots since the puck tends to fly off the same part of the blade every time. But for the sake of fairness in the game, the rules state that your blade cannot exceed 3/4 of an inch between the imaginary line from the heel to the toe. So like if I put my blade on the ice, the refs don't take out a ruler. They'd put their 2 fingers underneath, and if their 2 fingers can fit underneath while touching the blade, it's a legal blade. So this is a legal blade. Alright. Another feature built into the stick is the lie. The lie is the angle the blade makes with the shaft. For physics purposes, this will be represented by the angle theta. Players usually seek a lie that will leave their blade flat on the ice when they are in their playing position, like right here. The blade lays flat on the ice, so I can easily recept passes and give passes and shoot. The lie is expressed in a number. For example, my lie is 6, right? Typically, the taller you are, the lower the lie. So, like, if you're as tall as Chara, he's like 6'3", his lie is like 2, because he's in a much higher position where his blade has to be more at a steeper angle. Most players prefer to use carbon fiber because it is lightweight and has high strength for like taking slap shots. But there's a lot of slashing involved in hockey. There's not supposed to be, but it happens. This is important for control and easily being able to rip shots off because of the lightweight. You know, like you receive the pass and you're able to take a hard shot quickly.
Also, the high strength allows you to take slap shots. And we'll demonstrate that for you in the next video. This is a good example of how material science is an important part of the physics of hockey.
Alright, now I will be explaining the physics of the puck. First of all, the puck is made out of vulcanized rubber. It is very able to withstand the wear and tear throughout the game. The color black was wisely chosen so that it would stand out from the ice, so the players would be able to see it more easily. Prior to the game, the puck is frozen. This is done to reduce the friction between the puck and the ice, and this allows the puck to glide across the ice further and quicker without sticking to the ice. This is an advantage to the player so that he can maintain his momentum and still hit the puck. Instead, he would have to stop and hit the puck more often than he usually does. Without the low friction between the two surfaces, the player would have to stop and hit the puck and repeat that motion more often, like I said. Freezing the puck is also an advantage to the players because it reduces how much the puck bounces on the ice so the players have better control of the puck. This is a good example of how we can use freezing the puck to reduce friction, which friction is a part of physics, and that's how it ties into the game of hockey. Alright, the puck slides nicely across the ice because of low friction. Alright, lastly, we will explain the physics of the slap shot. The slap shot can hit up to speeds of 100 miles per hour, which the pros can, not us. But the player first raises the stick into the air and then hits the ice just behind the puck. During this, the player uses his weight to flex the stick or bend the stick. The stick now has potential energy stored in it like a spring. When the face of the blade strikes the puck, the player rotates his wrists and shifts his weight in order to release that potential energy stored in the stick and transfer it to the puck. The kinetic energy of the puck after impact is equal to the stored energy in the hockey stick. If the player just simply hit the puck directly without hitting the ice, there wouldn't be nearly the amount of energy or speed that it does when the player hits the ice first. The physics taking place here is the transfer of energy from the player to the stick, and then stick to the puck. So by the player striking the ice first and storing energy in the stick, it gives them an advantage. The stick then strikes the puck much faster than the player can, causing the puck to reach much higher speeds.
Now I'm going to be showing you how to take a slap shot and explaining the physics behind it. Alright, so you want to hit the puck or the ice about right there, and that creates flex in the stick, which is also called potential energy, and it will slide across the ice behind the puck, and when the face of the blade hits the puck, it will act as a spring almost and snap through, releasing all the potential energy, thus making the puck into a projectile, and it will strike the net, hopefully. And as you can see, I took a test run before and put a hole in the wall. So we're not going to do that. Come on.
Yeah. Alright, now, for example, here's a slap shot in action. Notice how he twists his body and he hits the puck, he hits the ice just before he hits the puck. Alright, now that we've explained to you the physics in a few areas of hockey, we hope that you learned something in the game of hockey. As there is physics in everyday life, many different sports, and obviously hockey like we showed you. There is a wide variety of different parts of physics involved in playing the game of hockey, and we hope you enjoyed our video. Thank you.